Hello and welcome to Module 8 of Fabric Fundamentals. My name's Alex and today we're going to be discussing real-time intelligence. So this is the one for all of you out there that need to see your data as it's generated. As always, I will be going through the theory that you'll need for the DP700 exam, and then I'll be doing a practical that you can follow along with, as I'll leave a link in the description. Okay, so let's dive in. So what is real-time intelligence? Real-time intelligence processes and analyzes data as it's generated, typically within seconds or minutes, and it enables immediate insights and rapid responses to events. It's also called near real-time because of the minor processing and network delays. And we can look at events, so records of system activities like clicks, purchases, sensor readings. We can represent discrete moments when something happens, or streams, continuous time-ordered sequences of events, and deliver events from source to destination for processing and analysis. The core components, we've got real-time data ingestion, where we're collecting data from multiple sources, so sensors, logs, APIs, as it's generated. Stream processing, which transforms and analyzes data in motion, so filtering, aggregating, pattern detection. Low latency storage, specialized systems for fast writes and quick queries. Interactive dashboards, visualizations that auto-update with new data. And automated decision making, event-driven rules, triggers, alerts, actions, or workflows. So what are the benefits? We've got immediate response to opportunities or issues, operational optimization based on current conditions, enhanced customer experiences via personalization, and proactive issue prevention through anomaly detection. Common use cases are delivery tracking, so we can monitor the vehicle locations and alert customers about delays, equipment monitoring, track machine temperatures to prevent breakdowns, fraud detection, analyze purchase patterns to block suspicious transactions instantly, website performance, monitor the page load times to enhance the user experience, and system health, track application errors to maintain reliability. So we've got the real-time hub. It's a central catalog for discovering and managing streaming data sources. It supports ingestion from Azure and external sources. It allows subscription to Azure and Fabric events, organizes data in motion into categories, data sources, Azure sources, Fabric events, and Azure events. And it enables preview, exploration, and automated responses based on streaming data. The real-time hub features, we have event streams, where we ingest and process streaming data from various sources. We apply real-time transformations, filtering, enrichment, and routing. And then we've got the event house, which stores real-time data in KQL, which is Custo Query Language, databases, optimized for time series data and fast ingestion, and it integrates with OneLake for broader data access. The KQL query set, workspace for running, saving, and sharing queries against KQL databases. It supports both KQL and T-SQL for flexible data analysis. The real-time dashboard connects directly to KQL databases, automatically refreshes as new data arrives, and enables interactive exploration of monitoring trends. The activator monitors streaming data against user-defined rules and triggers automated actions, notifications, workflows, pipelines when conditions are met. So there's two main approaches for ingesting data. We can use event streams, which we can directly ingest data into a KQL database in an event house. Event streams bring real-time events into Microsoft Fabric. They allow transformation, processing of data as it flows, and route processed data to a chosen destination. Event stream components, we have a source where the data originates from, transformations, so optional processing or filters that apply to the data, and a destination where processed data is sent. We have Microsoft sources, Azure Event Hubs, Azure IoT Hubs, Azure Service Bus, Change Data Capture or CDC, feeds in database services, and other Microsoft data services. Azure events, events from Azure Blob Storage. Fabric events, changes to items in a Fabric workspace, data changes in OneLake data stores, events related to Fabric jobs. And external sources, Apache Kafka, Google Cloud Pub and Sub, or MQTT, message queuing telemetry transport, which is in preview. Event transformations. We can take raw data from source systems. It's rarely in the ideal format for analysis or storage. Transformations make data useful and actionable as it flows through the event stream. We can filter the data, summarize or aggregate the data, reshape data, manage fields, expand, group by or join, and use SQL code for custom transformations. Data destinations. Streaming data is temporary and needs immediate processing and storage. Destinations make real-time data actionable and available for queries, reports, dashboards, alerts, actions, and integration with other systems. Possible destinations include a KQL database in an event house, lakehouse, derived stream, Fabric activator, or a custom endpoint. Ingestion into a KQL database. Data can be directly ingested into a KQL custom query language database in an event house. Supported ingestion sources include local files, Azure Storage, Amazon S3, Azure Event Hubs, OneLake, and more sources via the connectors or get data option in the KQL database. After ingestion, data lands in the KQL database and can be transformed using update policies. The update policies are automation mechanisms triggered when new data is written to a table. Run a query to transform the ingested data and save the result to a destination table. Difference from event stream transformations. Event stream transformations occur during stream processing before the data reaches its destination. And update policies transform data after it's ingested into the database. So storing and querying the data. KQL databases in an event house are used to store and query real-time data from event streams and other streaming sources. Once data is loaded into tables, you can query it using KQL, T-SQL, or within an event house, you can create KQL databases, which are real-time optimized data stores, host tables, stored functions, materialized views, shortcuts, and data streams. The KQL query sets are a collection of KQL queries for working with data in KQL database tables. Support queries written in KQL or a subset of T-SQL. So using KQL, and I'll put a link in the description to a really useful KQL cheat sheet. So you won't really need to learn the ins and outs of it fully. It's very similar to SQL, so it's quite easy to navigate. KQL is designed for analyzing large volumes of structured, semi-structured, and unstructured data with high performance. KQL databases are optimized for time series data, indexing by ingestion time, and partitioning for optimal query speed. KQL is used in Azure Data Explorer, Azure Monitor Log Analytics, Microsoft Sentinel, and Microsoft Fabric. The KQL syntax. Queries consist of a table name followed by operators like take, filter, transform, aggregate, or join data. And an example there is take 10 rows. We've got stock, take 10. And if we want to do an average stock price over the last 5 minutes, we'll have that there. This will come into play in the practical demo shortly. So visualizing real-time data, we have real-time dashboards which let you pin data visualizations to a single interface for instant real-time insights. Each dashboard tile displays information based on a KQL query, extracting real-time data from event house tables. You can create dashboards in a workspace and configure its data source, or directly from a KQL query set in an event house. Dashboards are made up of one or more tiles, each visualizing data from a KQL query. Default visualization is a table, but tiles can be customized to give you charts and graphs. Published dashboards allow interactive exploration. You can drill into the data, filter, aggregate, and change visualization types. And we also have Power BI integration, so we can create Power BI reports from the KQL database data. And we can automate actions with the activator. It's a technology in Microsoft Fabric for automated processing of events that trigger actions. The example uses, we can send an email alert when a value deviates from a range in an event stream. We can run a notebook from Spark-based processing when a real-time dashboard updates. The key concepts, we have events, each record in a data stream representing something that happened at a specific time. Objects, the business entity represented by the event data, so sales order or sensor. Properties, fields in the event data mapped to the aspects of the object state, so temperature or total amount. And then rules, conditions that, when met, trigger automated actions based on property values in events. Right, so now we will get on to the practical. As I said, follow along and we'll jump straight into it. Okay, so first thing we need to do is create an event stream, and we can go to the real-time section just on the left menu, and we can look towards data sources. For this one, we want to be connecting to the stock market data. So connect there, we'll call the source stock. And for the event stream name, we'll just call it stock stream. And just click next there and connect. From here, we can open the event stream. Don't actually call it stock stream because you'll end up with stock stream, which isn't great. So next we have the event stream here. This is the design canvas, and what we need is a destination for the data. So we need to create an event house. Now, best place to do that would be if we just go back to the workspace and go to new item and create an event house. Real-time intelligence event house. And just cancel all that. And here we have the overview of your event house. Down the left-hand side, you'll see your KQL database. And if we click that, this brings us into to the section where we can add the tables so that we can bring in the data. You can see underneath we have the query set, which by default will give you a couple of queries that you can get started with. So next, if we go back, we want to get data. And we can bring in the stream that we've just set up. So here we want to set up a new table. We'll call that stock. And just edit this here. So we'll have stock table. And just shift me there. And you can see that the data has been generated. So let's finish there. And close. And here we have the dashboard, the overview of that stream. So we'll just give it a chance to start generating some information for us there. So after just a couple of minutes, we've got some information showing us how much data has been ingested, and this is all real time. So let's go back to the stream, and we can see that the event house has been configured as the source. Sorry, the destination. Now let's go back to the event house, and we can start querying this data with our query set. And if you're following along with the practical, you can see that we've got some queries that we can run. So for this one, we've got the first 100, and there we can see our live data. And if we edit that to give us the average price, so this will retrieve the average price for each stock symbol in the last 5 minutes. And there we have it. So next we want to be creating a real-time dashboard. So from here we can save the dashboard, and we can save to a new dashboard and just put some information in there. So RTI dashboard, create that, and let's open the new dashboard. And there we have our new tile. We just need to select edit in the top, and then we've got the pencil icon here. So now in the visual, we can show the results, or we can show the visual, and we have visual formatting off to the side. So let's call it so average prices, and we can change the visual type. So we want a column chart, and we have a lot more options to play with here. But let's just apply changes. And there we have our real-time data on a dashboard. So now we're going to talk about creating an alert, and this is by far the most important thing about real-time data. We want to be informed as soon as one of our parameters is met. So we want to do that on average prices. Select. And from here, let's just call it alert test. So we've got a lot of options here. We can run the query every 5 minutes. We can even run it every 1 minute. And we want to set this to check on each event group by, and we're going to group by symbol when average price, and we're going to change it for a numeric change, increases by 100. And we've got a lot of different actions that we can take. The main ones are going to be sending messages on Teams or an email. We're going to send an email. I'll send that to myself. We can add whatever we want to there. We've got, let's just see, we've got create a new item, and yeah, we'll just call that activator test. So let's open up our alert, and it'll take us through to the dashboard for that. And from here we can see the analytics involved in the alert and the history. So how often it's been sent and when. Now it's not going to send me one straight away, so I'll send a test action just to show you what we'll get from there. And there you can see I've received the alert in my email. So this really gives us the ability to keep our teams reacting to data events as they are created. So that's real-time intelligence. As I said, I'll drop a link to the KQL cheat sheet below in the description. So give me a thumbs up and comment below if you do encounter this in the exam. Let me know if you passed the exam. I would love to hear that this has been beneficial. And subscribe for more. The next module is going to be Module 9, Scalable Semantic Models. So subscribe for that one. I'll see you on the next one.